Now that we know how to multiply and divide radicals, we can look at how to multiply and divide radical expressions. And just a reminder, an expression is just one or more terms that are separated by an operation such as addition and subtraction. So a radical expression is an algebraic expression that contains at least one radical. So at least one of the terms is going to have a radical. And the same principles apply to multiplying both polynomials and radical expressions with more than one term. So for example, if I have a binomial times a binomial, even if they have radicals in them, I still have to multiply them the same way. I can either use the FOIL method or the box method, whichever method you prefer. And using the FOIL method, I would have the first term, which would be the square root of 7, times the square root of 3, which would be the square root of 21. And then using the FOIL method, the outer terms, the square root of 7 times negative 6 would be negative 6 square roots of 7. And then doing the inner terms, the square root of 2 times the square root of 3 would give me the square root of 6. And then my last terms, the square root of 2 times negative 6 would give me negative 6 square roots of 2. And then looking at all these radicals, I see that none of them are the same, which means none of them can be simplified. That means that that was my final answer. Now looking at example 2, notice that this is a product of conjugates. And remember, conjugates are where the terms are the same, but one is minus and one is negative. Sorry, I meant to say that one is subtraction and one is addition, but notice that the terms are the same. And so when you have a product of conjugates, the square root of 5 squared, and then you have 7 squared. So I have 5 minus 49, and 5 minus 49 is negative 44. And so if you're a little lost on why I did not do this the same way I did example 1 when I multiplied binomials, the fact that it's a product of conjugates means that this is going to be the difference of squares. Because remember, the difference of squares, which is a squared minus b squared, always factors into a product of conjugates. So since this is a product of conjugates, that means that it's going to be the difference of squares. So it's going to be this squared and then this squared. And it's difference, so that means it's subtraction. So once I rewrite it as difference of squares, then I can go ahead and simplify. The square root of 5 squared is 5, and the 7 squared is 49. And then 5 minus 49 is negative 44. If that still confuses you, that's okay. You can still do the FOIL method or the box method to do this problem. So this is kind of just like a shortcut to make it go a little bit faster. If you can recognize that this is a product of conjugates, therefore it has to be the difference of squares, then it's going to just go a little bit faster. But don't worry if that, if you want to just multiply it using the FOIL method, absolutely, or the box method, you can do that. All right, so next example, we have the square root of 3 minus the square root of 2 squared. And this is a square of a difference, which means that it's going to be a squared minus 2ab plus b squared. So a squared, so the square root of 3 squared, minus 2ab, so 2 square root of 3 square root of 2, and then b squared, so the square root of 2 squared. Now, if you don't remember the formula for square of a difference, that's okay. You can just multiply the square root of 3 minus the square root of 2 times the square root of 3 minus the square root of 2, and either do the FOIL method or the box method and just multiply it like regular binomials. That's okay too. And now simplifying this, the square root of 3, 2 squared becomes 3. And then the square root of 3 times the square root of 2 is the square root of 6. So we have minus 2 square root of 6. And then the square root of 2 squared becomes 2. And then notice I have 3 plus 2, which is 5. So my final answer is 5 minus 2 square roots of 6. So here are the rules for multiplying radical expression. You're going to follow the same rules that you follow for multiplying polynomials. And then after you multiply, simplify the radicals and combine like terms. Here's another example. So this one, we have a binomial and a binomial and binomial, which means we have to multiply these two first, get an answer, and then multiply it by this. I don't know if you noticed, but this right here is a product of conjugates, which means that it's going to follow difference of squares. And the difference of squares say we're going to multiply a squared minus b squared. So we'll do a squared, so square root of 3 squared, minus b squared, minus 2 squared. And then we'll multiply that by the square root of 6 minus 4. So the square root of 3 squared is 3, and then the 2 squared is 4. So now we have 3 minus 4, which is negative 1. And then we'll distribute that negative 1 to the square root of 6 minus 4. So we get the negative square root of 6 plus 4. And then that will be our final answer. Except for, sorry, in mathematics, remember we like to list our integers first and then our irrational numbers. So we'll put the 4, we're going to use the community property to rewrite negative square root of 6 plus 4 and rewrite it as 4 minus the square root of 6. So what I did here, negative square root of 6 plus 4 is the same as saying 4 plus negative square root of 6. And 4 plus negative square root of 6 is the same as 4 minus square root of 6. So again, I use the community property, which is the property that says that a plus b is the same as b plus a. So when a radical expression appears in the denominator of a fraction, you multiply both the numerator and the denominator by the conjugate of the denominator. So it's very important that you don't just multiply by the radical itself, because you're never going to get the radical out of the denominator if you do that. So if you're remembering, just rationalize the denominator by multiplying by the radical, we can do that if it's not a radical, if it's just that radical term by itself. But when you have more than one term that have radicals in it, you have to multiply by the conjugate. Not just the radical, but the conjugate of the denominator. So for example, we have 4 plus the square root of 3 plus 5 plus the square root of 3. So to rationalize the denominator, you can't just multiply by the square root of 3 because you're going to still have a square root in the denominator if you do that. So instead, you'll multiply by the conjugate of the denominator, and the conjugate of this denominator happens to be 5 minus the square root of 3, because remember, a conjugate is same terms and then change from addition to subtraction or subtraction to addition. So this will be 5 minus the square root of 3, and we're going to multiply the numerator and the denominator by that. And so when we we're going to have to FOIL or box method the top, and then FOIL, or actually the bottom, you can FOIL or box method the bottom, or you can remember difference of squares. So when I FOIL the top, I get, for my first term, 4 times 5, which is 20. For my outer terms, I have 4 times negative square roots of 3, which is negative 4 square roots of 3. For my inner, I have the square root of 3 times 5, which is 5 square roots of 3. And then for my last, I have the square root of 3 times negative square roots of 3, which is minus 3. And then for the bottom, we're going to go ahead and use difference of squares. So 5 squared, which is a squared minus b squared. Our a is 5, so a squared is 25. our b is the square root of 3. So the square root of 3 squared is 3. So I get 25 minus 3 on the bottom. And then in this top, 20 minus 3 becomes 17. Negative 4 square roots of 3 plus 5 square roots of 3 becomes is 1 square roots of 3, or just plus square roots of 3. And then in the denominator, when I simplify, 25 minus 3 becomes 22. So here are steps for dividing radical expression. Place the dividend over the divisor. Multiply the numerator and the denominator by the conjugate of the denominator. And then simplify. Let's look at this example. So we had to multiply by the conjugate. So for this one, the conjugate would be 2 square roots of 3 minus 5. So we would multiply that by the top and the bottom. And then so we'll have to FOIL or box method at the top, FOIL or box method at the bottom, or use the property of the difference of squares on the bottom. So when I use FOIL on top, 3 square roots of 2 times 2 square roots of 3 is 6 square roots of 6. When I do my outer, 3 square roots of 2 times negative 5 gives me the negative 15 square roots of 2. My inner is 4 times 2 square roots of 3, which gives me 8 square roots of 3. And then my last is 4 times negative 5, which is negative 20. And then for the bottom, I'm going to use the difference of squares property since I'm multiplying, since I have a product of conjugate. So difference of squares says a squared minus b squared. So a is 2 square roots of 3. So a squared would be 2 square roots of 3 squared. Remember, I need to square the 2 and the square root of 3. So 2 squared is 4, and the square root of 3 squared is 3. And then 4 times 3 is 12. So the 4 times the 3 will be 12. And then 5 squared, which is my b, so b squared, which is 5 squared, is 25. So on the top, nothing simplifies. All of these radicals are different, which means that there are no like terms, which means my denominator does not simplify. My denominator simplifies because 12 minus 25 is negative 13.